Okay, so on this one, what we're going to do is we will go ahead and go through our guided practice together. Now we have, let's see, we have the guided practice, we have the independent practice, and then I have you guys doing the math practices on the back page as well. So what we will do is we'll go through the guided practice together. We'll take a quick look at the beginning of our independent practice, then we will break, have you guys work individually, independently on the independent practice and the math practices, and we'll come back together and we'll go through everything. I think that's all we have for, oh, we do have the homework practice page too. Oh, good, I'll give you guys lots of math for today. Excellent. No, this is good because you need to practice doing it. So, keep in mind though, whenever you have independent practice and homework and practice pages like this, I want you guys to make sure that you're prioritizing. What I mean by that is that you're doing these first, so these and the independent practice first. Don't get stuck on something on the back page on this one because sometimes they're a little bit tougher, okay? I don't want you guys getting stuck on it. So always, if you get stuck, move on and then come back to the harder ones, okay? That way you don't get stuck and you don't not finish. Brewer. Yes, go ahead. Essay. Good, I'm glad to hear that. Okay, so let's take a quick look at these what I have here. Okay. First one says, explain how you can use fraction strips to show whether 5/6 or 3/6 of the same whole is greater. Who can tell me? How can we use fraction strips? Remember kind of those like the banners and the other one? Yeah, how can we use those to show which one's greater?
We can make a whole and then put 5/6 and 3/6 and see which one is closer to the whole.
There you go. Okay, so we could do that. That's right. We could do it just like this, right? So we could draw out one hole, and then our goal then would be to draw out other ones that look pretty much just like it, right? Except this one we didn't break up, and this one we're going to. Now we have 6 pieces. We broke it in that hole into 6 pieces, right? Each one of them. This one, though, now we need 5/6. So 1, 2, 3, 4, 5. And the bottom one we need 3. 1, 2, 3. So this is 5/6, and this one is 3/6. Which one's greater? Is 5/6 or 3/6 greater? Which one's greater? Schmidt?
5/6.
5/6. And how can you tell? How can you tell, guys? Hurry on. Go ahead. Say it a little bit louder. The numerator is different than the denominator. That's true. But isn't 5 closer to 6 than 3? 5 is closer to 6, right? Now, if I had drawn this right, you'd be able to tell that 3/6 is also 1/2. Right? Because it would be right straight down the middle if it was drawn for 3/6. But isn't 5 parts out of 6 closer to 6 than 3? Yeah, exactly. You can tell because it's closer, right? So if this is the beginning of one hole and that's the end, doesn't the 5 isn't it closer to it? And you guys can see that, right? Sort of like with the banners. If we had drawn them like the banners, right, on the other page, and we had said, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and I asked you which one of these has, which one of those banners has more pink? Which one? Jack, which one? This one right here, right? Exactly, because it's 5/6, and the other one is 3/6. Wilkins, go ahead. There should be some right in that middle basket there. So good. We've got a couple different ways we can show that, right? Now, what about if I go to the wrong page? Let's look at number 2. Which is greater? 3/4 or 2/4? So it asks you, which is greater? Greater. 2/4 or 3/4? Draw 1/4 strips to complete the diagram and answer the question. So you have to complete the diagram and answer the question. Remember, circle, highlight, underline the important information. Make sure, no matter what, even if I'm going over these with you, that you are reading the instructions fully, so you're doing everything they ask, okay? So in this one, we've got the whole. Now, it says complete the diagram to answer the question. What do I need to do next? What do I do next? Allie, what should I do now? How do I get 3/4 and 2/4 on that? What do I do? Allie, did you write down the other one we just did up here? I can do the same thing, or should I do something like this? It's basically exactly what we did over there, right? Is that what I should do? Zoe?
I know. And the E would be and basically
You're right. So that means that we're talking about dividing this 1 into 4 parts, right? Because the denominator is 4. So if that's the case, then we should have, if we did that, it'd be like that, right? So we should have 1, 2 out of 4 would be here. Well, let's do 3 out of 4 first, right? 3 out of 4 would be here. And then 2 out of 4 would be like this. Now, what Zoe said is to write in them, right? So in this one, we could say 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, right? Something like that?
Yeah.
Yeah?
So I also always write my algebra.
You do what?
I write my algebra.
Oh, okay. So in this case, we've got 3 1/4 strips, so that's 3/4. And the next one we have 2. Now, other question is, what is 2/4 equivalent to? What's 2/4 equivalent to? Come in.
1/2.
It is 1/2. See? Straight out. Yes, you can. 2/4 is 1/2. And 2 is half of 4, right? So, we do like that to complete the diagram. And we're answering the question, which is greater? So Zoe said she used the alligator as well. So if I was to write out 3/4 and 2/4, Allie, where would I put the alligator? Which one does the alligator want to eat? 3/4, because it's more, right? Yes, go ahead. Does that make sense, guys? Thumbs up? Good. Good. Okay, so now let's look at, go up a little bit here. In 3 and 4, we're going to compare. So we're going to use our symbols, right? Our greater than, less than, or equal than symbols. Use the fraction strips to help. So we've got the diagram on 3. We have a diagram there, right? Jack, question? Say a little bit, I'm sorry, say a little bit louder, I can't hear. On this one? What is the answer? That's right. And you can see it because this one's 2/8 right here, right? And this one is only 1/8. You guys see why I'm just writing this in next to it. I'm not saying that that's what goes there. I'm just writing it next to it. Maybe it'll be clearer first on the other side. Let's move it. There we go. Whoa, or do that to it. That's not what I meant to do. There we go. That kind of works. Okay. But you guys can see that 2/8 is greater than 1/8, right? You can see it just by looking at it. Brewer. Let's look at that. On number 4. Number 4. We have, this one is 3/6, right? And that one is what? What's the bottom one?
5/6.
That's 5/6, right? Because we have 5 1/6 P6. Which is greater, 3/6 or 5/6? 5/6 is greater. 5/6, that 5 is almost all the way at the end, right? See how much longer it is? It's a better deal. You're getting almost the entire thing. If this was like I'm trying to think of something like a Kit Kat. That'd be if somebody gave you 5/6 of that Kit Kat. Isn't that better than just getting 1/2? Because isn't 3/6 the same thing as 1/2? Deva? Is 3/6 the same thing as 1/2? Yes, it is. It looks like it for one, right? You can see it. But also, is 3/2 of 6? It is, right? Wouldn't it be a better deal if I said to you, Teva, I'll give you 5/6 of this Kit Kat. It's one of those giant Kit Kats. Then 1/2. It'd be better, right? So then you, if you were the alligator, you get 5/6. Yes. Oh, you don't like Kit Kats? Well, okay, bad example for you then. Maybe it's some other long candy. I don't know what else is. Twix. Twix work. You like Twix? Those are pretty good. Okay, guys, we're not talking about candy. I'm just using it as an example. Okay, so do these make sense? Does everybody have a pretty good idea of what we're looking for here? Feel pretty good about it? Thumbs up? Go ahead, Schmidt. Yeah, sideways thumbs? Okay, give me some thumbs up if you think this makes sense. You can do this. You're going to do well on the independent part. Good. That's true. Sideways thumbs if you're getting there with it. You're getting there. And I know the sideways and down, you don't like it, but you're getting there. I got you. Okay, so most of you are getting there. Okay, so let's go ahead and work on the independent practice section first, right here. This is pretty easy, guys. Look what they're asking you to do. You're just comparing most of it. Using the symbols. If you need to draw fraction strips down here, draw the fraction strips. But I think in most cases you're not going to need to, right? Because when the denominator is the same, the numerator matters. It means that the numerator, if the numerator is greater, whatever number is closer to the denominator, means that one's going to be bigger, doesn't it? Like if we were looking at this one, isn't 4/8 bigger than 3/8? Am I right? Allie? That's exactly right. Whichever one's the greater fraction. Esther? Okay, good. So guys, work on I don't think this is going to take you long. Independent practice section right here. Then, make sure that you also do this page here. The homework and practice page. 689 on it. And then go back and do this one here. Read these carefully because some of these are word problems. Okay? But our goal is to get all these set. So what we'll do is we'll come back to this and review it together at about, I'm going to say 9:15, unless we all finish sooner than that. Okay? So let's go ahead and get started. That's right. I think it's spring break-itis. Okay, guys, let's go over this together. Does anybody have a question? I'm sorry, what? Oh, no, that's okay. I'll do it over recess. But thank you. Okay, guys, so everybody, go ahead and go back to the very first page of math. In the back is the one that says independent practice under the guided practice section that we completed together. Everybody should be on this page. It says 687 at the bottom. Right there. So 687 at the bottom. Everybody should be on that page. If you are not on that page, please turn to that page now. The one that we started together up here, April 6th. We did the top part. Let's go over the independent practice section. Everybody on that page? Independent practice? That's the question. Yes, please do. Good. Nick's got it. Okay. So let's take a look at these. Let's start with our number 5 here. Remember, it says to compare. So we're looking at two different things. And we're seeing if they're similar or different, right? And then we're going to use our greater than, less than, or equal symbols. Down here it says to draw fraction strips to help. If you didn't do that, that's okay. If you know these already, then that's perfect. That means that you're understanding this concept. Okay, number 5. So here's our whole. We have right here 3/8, and right here we have 4/8. Which is greater, 3/8 or 4/8? Hester?
4/8.
4/8 is greater. Everybody get that one? And you can see it, right? Look how 4/8 is greater. Now, other question, bonus question. What is 4/8 equivalent to? What's it equivalent to, guys? Allie? It's 1/2. That's right. It is. It's the same thing as 1/2. Good. Okay, number 6. We have 3/4 and 3/4. What is that one? Tama?
Equal.
They're equal. It's the same. It's the same. And in this case, you can tell it's the same because look, it looks exactly the same. Not only are the fractions equal, they actually are the same. The shape is okay. Number 7, 6/8 and 3/8. Brewer, which one's greater? 6/8 is greater. Why is 6/8 greater? Brewer, why is it greater? Well, 6 is a higher number than 3, isn't it? So in this case, because the denominators are the same, because we're talking about the same whole, we're talking about the same number of parts that the whole is cut into, right? That means that 6/8 is greater than 3/8. When we start talking about different denominators, you're going to notice that the numerator doesn't always mean that it's higher, that it's greater. It really depends on whether or not the denominators are the same, right? So, what about 5/8 and 7/8, Zoe?
7/8
That's right. You're right. There's only one left, right? 1/2 and 1/2, Heston.
equal. It is equal.
They are equal.
This is a goal. I'm not trying to read. This is like kindergarten.
Oh, is it? I'm pretty sure kindergarten can't do fractions, but I'm glad you think it's easy. That's good. That means you guys are getting fractions. That's a good thing. Don't worry. It'll get more difficult. Sally.
How does the next one?
1/3 and 2/3. That's right, 2/3. What about this one? 6/6 and 3/6. 6/6 and 3/6. Schmidt.
6/6.
And what, Zoe, is 6/6 equivalent to? It's not equivalent to 6. It's equivalent to what, though? If you have 6 parts out of 6, it's
1 whole.
Everybody say it?
1 whole.
It's 1 whole. Imagine if we drew it out, right? And it was cut into 6. Those are really bad. Okay, that's a really bad drawing. But imagine they're equal. And I gave you the entire thing. All 6 parts. That's 1 whole, isn't it? Anytime your numerator and denominator are the same, 1 whole. So 1 whole is definitely going to be greater than, what's 3/6, guys? What's that equivalent to, Nick?
3.
Oh, this one is 3/8. Yes, that is correct. But what is 3/6 equivalent to, guys? Alec? 1/2. So 1 whole is definitely going to be greater than 1/2. Nick's right. 3/8 is greater than 2/8. What about 3/3 and 1/3? 3/3 and 1/3. Wilkins.
3
3/3 is greater because 3/3 is equivalent to what?
1
1 whole. What about 1/4 and 3/4? 1/4 and 3/4. Who wants to answer that one? Taba? 3/4 is greater. That's right. And why is that? Zoe, why is that? Why is 3/4 greater? she's looking at me like I'm crazy. She's like, because of course it's bigger. Because this time you have 3 parts out of 4, right? Then better deal if I gave you 3 parts out of 4 than just 1 part out of 4, right? Make sense? No.
I'm just trying
Okay, I understand. Okay, guys, let's skip over to this one first, and then we'll come back to the other one. This is the homework and practice page. Esther. Serious. Okay.
How is the alligators in the equal word? Because it doesn't have
Alligators have teeth. You mean in the draw? You could draw the teeth in. I see some of you guys do draw the teeth in. You don't have to, but you can. So. Okay. Let's go to this page, guys. So this is not this is not the second page, it's the third page. Go ahead and skip over to this one. I bring down this one. Now, quick reminder on the top here. Anytime, go ahead, you see a page that says another look, because I think a few of you guys were a little confused here. Please don't make your lives more difficult. This is just a reminder section. If you read the whole thing, and I want you to, they give you the answers. So there's nothing you have to do on that part except for read. So it says you can use fraction strips to compare fractions that have the same denominator. But you guys do that, right? Because we've done it. And there's an example right here. They're comparing 1/4 and 3/4, right? Then this guy over here says fractions that you compare must be part of the same whole or of equal sized wholes, right? Of the same whole or equal sized wholes. Now in this case, we know that even if we had 1 whole, 2 whole, 3 wholes, they're all going to be the same size. They're all divided into 1/4. Okay? Now it says down here the denominator for each fraction is 4. Use fraction strips to compare, which is exactly what they did right here. Use 1/4 strip to show 1/4, and 3 1/4 strips to show 3/4. More 1/4 strips are used to show 3/4. So 3/4 is greater than 1/4, and 1/4 is less than 3/4. We're saying the same thing in different ways. So again, in this section up here, anytime you see the top section, usually there's a little person there. They've got some information to read. This area here, it's just for reading. There's no real work you have to do here. You just have to read it. Because it reminds you. It actually is there to give you guys a reminder about how to do this work, right? Aston, question? Question? No question?
Okay, no.
Oh, good. Now, down in this section, let's go over these. We're doing it again. We're comparing. And then we're writing greater than, less than, or equal to. And again, it says the same thing. If you need to draw the fraction strips to help you do it, you have to know how fraction strips work. That's the idea. What I'm more concerned about is that you guys understand the fractions even without seeing the fractions. But the fraction strips are there to help you. So if you need to draw them out, please do. But also, when you see them, like in our tests in class, or on the state test, if you see them, at least you know how they work. Okay? And when you see the words fraction strips, you know what that means. Or what those words mean, okay? Let's see, we've got 1 whole. Now we have 4/8 and 5/8. Zoe, which one's greater? 5/8. What is the next one? We have 3/4 and 2/4. 3/4 is greater. That's right. 2/4 is equivalent to what, guys? What is 2/4 equivalent to, Allie? 1/2. And you can see it, right? It's right down the middle. Right down the middle. What about number 3 here, guys? 2/6 and 5/6. Which one is greater? 2/6 or 5/6? Jack? 5/6 is greater. What about 1/3 and 1/3? 1/3 and 1/3. Brewer? They're equal. Wilkins, what about 4/8 and 4/8?
Equal.
Equal. And also, what is 4/8 equivalent to? Wilkins?
1/2.
1/2. Because 4 is half of 8, right? 4 is half of 8. What about 2/4 and 1/4, guys? Nick? 2/4. What about 7/8 and 1/8? Heston? 2 things.
7/8.
7/8.
And also,
Yes.
paper towels.
One more time?
And I do paper towels.
Oh, paper towels. Okay, let's talk about that in a little bit. I have a list, but I think those might be old. But we'll talk about it, okay? 2, 6, and 3, 6, guys. Everybody, 2, 6, and 3, 6.
3, 6.
3, 6. 5, 6, and 5, 6.
Equal.
1/8 and 2/8.
2/8.
4, 6, and 2, 6.
4, 6.
And 5, 6. Good. So these are pretty easy, aren't they?
Yeah.
They're not too bad.
Too easy.
Okay. Well, let's look at that middle page then, since you guys are telling me those are easy. I know some of these are a little more challenging. Let's take a look. We're going to use the pictures of the strips that have been partly shaded. Again, I know that in the packet these aren't showing up in your workbooks. Of course they do. But you can also draw them up here. So, this section we have 1/6 and 2/6. Which one is greater, 1/6 or 2/6? Alex?
2/6.
2/6. That is correct. Do the yellow strips. Now, remember, when you see something that says explain, it means they want a sentence. And what do I want? When you guys write a sentence?
Caps.
Caps. That's right. I want capitalization, accuracy, punctuation, and spelling. One complete sentence, and I want you to restate. So in this case, it says, do the yellow strips show that 2/4 is greater than 3/4? Do they show that? Do they show that? Ian?
No, the yellow strips show that 3/4 is greater than 2/4.
That's right. That's right. No, the yellow strips show that 3/4 is greater than 2/4, right? 3/4 is greater than 2/4. Is that what everybody has? I hope so, because they were trying to fool you. They were trying to fool you on that one. Schmidt.
2/4 is not greater than 3/4 because 3 is bigger than 2.
You can say that. You can say that. But you can see it here as well, right? Well, let's talk about that pizza one. Let me talk about that first because I know that we have a couple different arguments on that one. Izzy and Henry have two, here's the important part, guys. That's what I always say. Circle, highlight, underline the important information. They have two different pizzas. Izzy ate 3/8 of her pizza, Henry ate 3/8 of his pizza, but Izzy ate more pizza than Henry. How is this possible? And again, explain. Now, I want to get arguments on both sides of this one, okay? Who told me that it's not possible? Who said it's not possible? Talon? And why did you tell me it's not possible? So, Talon is saying these fractions are equal. The fractions are indeed equal, 3/8 and 3/8. However, it is possible that Izzy actually ate more pizza than Henry. How is it possible, Schmidt?
Because this is possible because Izzy had a bigger pizza than Henry. Henry can have a really small pizza and Izzy can have a really big pizza.
That's right. It's possible. It's possible. Because Izzy's pizza might have been like a medium, right? Cut into eighths. And Henry might have had an extra large. The fractions are still both 3/8, right? But look. Henry's pizza is bigger. So that means that he ate more pizza. Oh, excuse me. I mixed them up. Henry's pizza is the little pizza. Izzy's pizza is bigger. Izzy ate more pizza, right? You guys see what I mean? Heston.
Or she just ate one more bite, 3 or 2 more bites, and the other
But then it wouldn't be 3/8, right? You're right. I mean, in actual, yes, we were talking about a real life scenario. That could be very true. But we're talking about specifically 3/8 of the pizzas, right? Zoe.
But it didn't say it in
It doesn't say that, but that's why it's up to you guys to explain. And I'll accept arguments on either side, as long as there's an explanation. As long as you guys can say to me, no, it's not possible because they had the same size pizza and they both ate 3/8. You could make that assumption, but it doesn't say that either. It also doesn't say the pizzas were the same size. All you know is what it told you, which is that Izzy ate more pizza. How is this possible to explain? Right? Schmidt.
And it was actually giving me a hint that it said two different.
And it does say 2 different pizzas. Now, it is true that those pizzas could have been the same size, but it doesn't tell us that. All it tells us is that Izzy ate more. So then we're making the assumption, or what we call an inference, where you're taking information you know that they've given you, and you're coming up with an idea of what the answer is based on that information. So what I would go with is that indeed it is possible because Izzy could have had a bigger pizza than Henry. So it is possible. Does that mean 3/8 and 3/8 are still equal? Yeah, 3/8 and 3/8, if you just look at it on paper, 3/8 and 3/8 are still equal. They ate an equal fraction of each of their pizzas, but the amount of pizza wasn't the same. Does that make sense? Kind of make sense? A little bit? Real.
Or was the bigger pieces.
3 bigger pieces? Well, how would they have cut them into 8 equal pieces though? If they were the same size pizza, you wouldn't be able to have one pizza that was cut into bigger slices than the other. Because they'd be 8 equal pieces. The goal with fractions is to have equal pieces, right? Which means that you couldn't have had a total here. Yeah, 3 giant pieces. That's what and they would be equal. Make sense? They'd be equal. That's the goal anyway. Now, of course, sometimes when you order pizza, it's not always cut equally. But that's not the point. In our fractions world, our pizzas are always cut perfectly. Alex. Larger pizza than Henry?
Yeah.
Yep, you can say that. You can say that. But
No offense, but I think I did pretty good on this one, so that's everybody else.
that is not a very nice thing to say, though. You did well, but that doesn't mean you want to brag about it. We talked about bragging. Everybody else had good arguments, too. Now, I just happen to agree with this one based on the information that we have. Okay. 2 fractions are equal. Guys, remember, highlight, circle, underline the important information. Again, I do not say that because it's fun to say. I say it because I want your lives to be easy. Okay? I want you guys to continue thinking fractions are easy and math in general is fun, but you're not going to think that if you're not able to see what the important information is, right? 2 fractions are equal. They also have the same denominator. What must be true of the numerators of the fractions? Explain. If these are equal fractions and they have the same denominator, what has to be true about the numerators, guys? What has to be true about the numerators? Schmidt.
Everybody did really good, but I just
Okay. What must be true of the numerators, guys? If these are equal, they're equal fractions, they have the same denominator, Jack. What has to be true about the numerators? The numerators also have to be equal. That's right. If they're equal fractions, let's say we've got 3/8. And because they already tell us they have the same denominator. That means if they have the same denominator, that the numerator has to be the same. Has to. Okay, that one's right next to you. I'll get it. So it has to be the same. Does that make sense to everybody?
Yes.
Good. Because the numerators are the same. I'll do it this thing. Really, oh my God.
It's gonna make it mad.
I did. Okay. Turned out this was a bad thing. The ruler was better.
There you go.
Yeah. No, not that ruler. We got it. Oh, we got it. We got it. You heard the crunch.
Oh, it's leaking.
Oh, this is the hand sanitizer that you guys don't
No,
want.
no, no.
What's that? You want to use it?
No.
You want
No, never. Playing with it.
That may not have been a good thing either.
to? Yeah.
Is it all wet?
That is the weirdest.
No, I'm
thing
not
I've ever-
smelling my hand because I know I don't like the smell. Gotta wash my
Okay.
hand now.
Yeah, it's weird hand sanitizer, that one. Okay.
Otherwise.
Oh no, it's horrible. I know. I have no idea. I know, guys. I know.
Relax.
Sorry. Chill.
Relax.
We can open the door more. Except, is it loud out there? I think they're all going back inside. Okay. Class. Okay. Focus. Go back to this. Number 19. Mr. Domini had $814 in the bank on Wednesday. On Thursday, he withdrew. Remember what I said about withdrew? What does withdraw mean? Or withdrew? What does it mean, guys?
Take it away.
You're taking it away. So he withdrew $250 on Friday. He withdrew $185. How much money did he have in the bank then? So, first question. I don't want to hear calling up. Put your hands up if you have the answer. First question. What is the operation? What's the operation? It's subtraction. That's correct. The operation is subtraction because he withdrew money. So we're going to take 814. First, we're going to deduct or subtract 250. That's the first step we're going to take, right? First step. Jack, what's our answer when we take 814 minus 250? What do you think? Let's look at it. 4 minus 0 is 4. We have to borrow from the 8 to make this 11. 11 minus 5 is what? 11 minus 5 is what? 7 minus 2 is what? 7 minus 2 is what? So our answer for that is 564. Now, we're not done though. We also have to take away 185 because he made a second withdrawal, right? Second withdrawal. How much money do you have in the bank then? So 564 minus 185. Schmidt.
It equals 145.
What is it?
145.
Well, let's take a look at it. We have to borrow from our 5 here, right? We're going to make that into a 4. To make this into a 16, we have to borrow from that as well. Because you can't take 5 away from 4. So, but you can take 5 away from 14. Right? What is 14 minus 5? 14 minus 5. Allie? That's correct. Now what's 15 minus 8? 15 minus 8. Jack? 7. And then what's 4 minus 1? 4 minus 1. 4 minus 1, guys. Everybody knows this one. Yeah. So our answer then is, yeah, and I'd rather have you guys write Mr. Domini had. He had $379 in bank. that make sense? Right.
Wait, what would you minus from 185?
We're not taking anything away from 185. We're taking 185 away from 564.
Well, I was minusing 250 minus 185.
Well, you don't want to do that because you need to take 250 away from 814.
Oh my god.
This is a two-step problem. Remember, guys, highlight, circle, underline the important information. You got 379 O's in the book. Does that make sense, guys? Make sense? So.
Gravity never pays off.
Oh. Okay. Next one. Tom's parents let him choose whether to play his favorite game for 7/8 of an hour or 8/8 of an hour. Explain which amount of time you think Tom should choose and why. So, hey, hold on. Heston, you gotta put your hand up. Gotta stop calling out. Heston. Why?
Every kid would pick the biggest number.
Never get a biggest number. What is 8/8 equivalent to, guys? What's 8/8?
1 whole.
So, did they tell him he could play it for either less than an hour or an hour? They did, didn't they? Wouldn't you choose an hour? Oh, okay, so Jack said no because he doesn't like board games. So he thinks Tom should choose 7/8 because he doesn't like board games. But this is implying, we're inferring that Tom likes board games because it says his favorite board game for 7/8 an hour. So somebody give me one complete sentence. Jack.
1 hour because it's his favorite game.
That's good. I like that sentence. That's good. Yeah.
I think you should put 808 hours because it's long.
That's right, because it's longer. Exactly. Because 8/8 is equivalent to 1 hour. 1 hour is longer than 7/8 of an hour, right? Heston. 3 of them.
That's right there.
That's true.
That's my name.
And third thing.
My dad's name is Thomas Weaver. Mine is Heston Weaver. And the baby goes is Tom.
Okay, good to know. Sellers.
My longest time I've ever played a board game, which was Monopoly, the original one, was 3 hours.
Yep, it can take a long time. It can.
Cool.
Yep.
Cool.
My wife and I played a board game yesterday for probably 12 hours.
What game?
It is called Lord of the Rings Journeys in Middle-earth. Very long game. Still not over. Tell it.
I thought you were talking about an arcade game.
An arcade game? Well, that would be fun too. And you could apply it for the same thing, right? Which would you rather play? An arcade game for 7/8 of an hour? Or a full hour?
Full hour.
Full hour, right? Allie. Guys. Yes. That's a good one. That's a good one. Okay, guys. Let's look at these last couple ones here. The picture below, and again, I know some of this didn't show up in your packet. So you can either see it here or in your workbook. The pictures below show tile designs. Which shows 4/8, which shows less than 4/8 of the whole shape? Which one of these shows less than 4/8? Allie? Which shows less than 4/8? That's right. C. That's exactly right. Which makes it what, Talon? Okay, yes. Hold on a minute. What is C then? What is C then? If it's not 4/8, what is it? Esther? It's 3/8. That's what it's 3/8. So this one right here is 4/8. This one right here is 1, 2, 3, 4, 5, 6/8. And this one is 1, 2, 3, 4, 5/8. So the only one that is less than 4/8 would be this one. 3/8. Okay, now Talon This one says these fractions refer to the same whole. Which of the comparisons is not correct? Which one of these comparisons is not correct, Helen? D. That's right. Because 1/3 is not bigger than 2/3, right? Allie, go ahead. Heston. Want something on your head? Okay. Does that one make sense, guys? Good. Good. Oh, is it a little scab? Looks like a little scab. It looks like a tape. But it doesn't look like a tape. Okay. So guys, do we have any questions on the math, or is this all making sense to you? Thumbs up? Yeah? Aiden, question.
I didn't get 18.
You didn't get 18. Now remember, guys, I want you following along, not just copying down answers. So on that one, what part of that one didn't work for you, Aiden? What answer did you get?
18?
Yeah, what did you get on oh, I'm on 19, I'm sorry. On 18, what did you get? Oh, you didn't understand that one. Okay. So guys, because the denominator is the same, let's talk about that one more time. Because the denominator is the same, and they were asking us to explain to them why the two fractions are equal and what the numerators have to look like. If the denominator is the same, it means the numerator has to be the same too for them to be equal. So anytime that you see a fraction if you see a problem like this, or that asks you something similar, if you see a fraction or a set of fractions that have the same denominator, and the question asks you if those fractions are equal, or how to make those fractions equal, the numerators have to be the same too. Does that make sense? Because we're talking about, in this case, imagine that you have, it's kind of like this one over here. These fractions are still equal, 3/8 and 3/8, right? The fractions themselves are still equal. This is where it gets a little bit weird, I know. Henry and Izzy ate the same fraction of each of their pizzas, but they did not eat the same amount. But they still ate, their fractions are still equal. In this case, it's kind of, you could apply the same thing here. These might be exactly the same. They might be the same shape. They might be the same exact size. Or they might not be. Right? They might look exactly like that. Or one could be gigantic. But the fractions are still the same. 3/8 still equals 3/8. So the fraction is still the same. You're eating the same amount or taking away the same amount from the whole. Does that make sense? Yeah, kind of? Okay. Great question?
If the denominator is the same, the denominator is the same.
Numerator, yes.
Sorry.
Yes. If the denominators are the same, if you want your fractions to be equal, and you have the same denominator, then the numerator must also be the same. That's right.
That's why I didn't put denominators in the
I understand. It's okay. It's okay. Okay, guys, any other questions on the math? Feeling pretty good about it right now? Good. Thumbs up? Yeah? Good, then we are done with our math for the day.